So we are looking at lesson 5-6, our homework assignment 3 through 23. Starting with number 3. It says, suppose a multiple choice question has 5 choices, A, B, C, D, and E, and Jasmine guesses randomly. What's the probability that she will get the answer correct? Assuming that there's only one right answer, that would be a 1 out of 5. And if you check the answer key, they turned that to a percent. So you divide, you get 0.2, that's 20%. So you can express it as a fraction or a percent. And part B, what's the probability that she will miss the question? Okay, so kind of like the opposite, or that would be the complement. That's what we call it. So if 1 out of 5 is correct, that means 4 out of 5 is incorrect, and that's 80%. And so as you look at these two, they add up to 100% and they add up to 1 if you're dealing with the fractions, and that makes them complements. Number 4, picking a number from 1 to 25. How many outcomes are possible? Outcomes is just the total number, so there's 25, 1 through 25. If it was 0 through 25, then we'd add one more, and it'd be 26. So we have 25. Part B, what's the probability that you pick the number 17? So from 1 to 25, how many times do you see the number 17? That would be just once out of 25. Now, in the book, they're going to express that as a percent. And so let's make sure we know how to do that. As 1 out of 25. Go ahead and just divide. 0.04, move it over. That's 4%. Letter C. Let E equal, you pick an even number. What is the probability of E? So what is the probability of picking an even number? So you'd have to count them up, 2, 4, 6, 8, 10, 12, all the way up to 24. You're going to have 12 total out of 25. Okay, and if you go ahead and you divide that, that's 48%. Letter D, same thing, but now it's an odd number. So if 12 out of 25 are even, that means 13 out of 25 are odd. Add those up, you should get one whole. So over here, I don't even need the calculator. I know the percent is going to get me to 100 from 48. So it's 52%. And you could double check it in the calculator, divide, you'll get 0.52. And letter E, like I just talked about a little bit here, these two are going to add up to 100%. There's no other possible outcomes. You're either going to get an odd or you're going to get an even. Those are the only possible outcomes. Okay, and they add up to 100%, so those are called complementary. Okay, number 5. So it says, examine the probability distribution in this lesson for the sum of the numbers on 2 fair dice when they are tossed. And if you flip back in the lesson, which is what they want you to do, you'll see the distribution of rolling 2 dice. So the lowest number you could get is a 2. They said, again, let's go back and read it. It says the sum of the numbers. That means adding the numbers. So you could get a 2 by rolling a 1 and a 1. That's the only way to roll a 2. So the smallest number you can get is a 2, and the biggest number you can get is a 12. So again, they're not talking individual dice. They're talking about the sum of the dice. You roll 2 dice and you add up the numbers. Smallest number is a 2, biggest number is a 12, and lots of stuff in between. You'll notice there's only one way to get a 2. There's only one way to get a 12. Okay, a couple ways to get an 11. 7 is the most common. Those that had me in 7th grade, remember we used to roll dice for partners. 7 is the most common, 2 and 12 the least common. Okay, so if you take a look, there's 6 rows and 6 columns, so that means 36 total outcomes. There's 36 different combinations that we're looking at right here. So it says, what's the probability of a 2? So again, this is the sum, not a 2 on one dice, a 2 on as the sum of both dice. So we just looked at it. There's only one way to do it. Out of all of these 36 combinations, there's just one. So this is a 1 out of 36 for part A. What's the probability of rolling a 13? Well, we just talked about the biggest number you can get is a 12, 6 and 6. So the probability of rolling a 13 is just 0. What's the probability of getting a number less than 5? So if we flip back to this, we got to count up all the different ones less than 5. So they're all going to be up here with the smaller numbers. Here's 5, here's 5, here's 5. And those kind of make a line. 5, 5, 5, 5. Everything above that line is going to be one that's less than 5. So I've got 1, 2, 3, 4, 5, 6. I have 6 out of 36. And that can simplify. Divide those by 6. And so it is a 1 out of 6 chance. Okay, number 6. Use the information on blood types found on page 283. So we've got that right here. Letter A, which blood type is the least common? So they have all the blood types here from O positive to AB negative, and this is the percent of people that have each one. And so the least common would be the smallest percent. So as you look through this, 0.7 would be the smallest percent. And so that's type A, B negative. And letter B, what's the most common blood type? So that would be the highest percentage. And you can see the 38.4 is the highest percent. And so that's O positive. Okay, number 7. Still looking at this. What's the probability that a person has type B blood? So there's 2 types of type B. There's B positive and B negative, but those both are type B. So you have type O, type A, type B, and type AB. So type B is just these 2. So it's 9.4 and 1.7 together for a total of 11.1%. Just adding them together, 9.4 plus 1.7 is 11.1. Letter B. What's the probability that a person with type B blood is B positive? So not in general, out of everybody, all the different blood types, what's the probability of B positive? That would just be 9.4%. But they're talking about, you take everybody who's type B, and out of those people, what's the chance that they're B positive compared to B negative? So there's a 9.4% chance out of the total that they're B positive. We're comparing that to just the B's. So the total number of B's is 11.1%. So out of the 11.1%, 9.4% are B positive. We're going to go ahead and divide those two numbers. And again, that's a percent. Move it over. About 84.7%. And then part C, what's the probability that a person with type B blood is B negative? So that's just the opposite now. So if there's this percent for B positive, then that means the other number is going to add up to 100% with this. So you could just subtract this from 100%. But going back to what we were doing, we're looking at 1.7 and comparing it to the total, which again, we're just looking at type B blood. So out of that, so 1.7 divided by 11.1. Move that decimal 2 spots. That's about 15.3%. And again, if you added the 9.4 and the 1.7 up, get the total. So you get one whole here. And if you added up your percentages, you're going to get 100%. Letter D, the probability in part C is called the blank probability that a person with type B blood is B negative. Okay, and this is conditional. Now you might have been thinking complementary. Okay, but it's not complementary because we're specifically talking about this smaller subject out of the total. So complementary would be O positive and everybody else, or type A and everybody else. Those are complements. Those make up all of the possibilities. We're just looking specifically at B positive and B negative, okay, in that subgroup. So that's a conditional case. Conditional is the right word. They're not complementary because we're not dealing with any of these other percentages, other blood types for the total. Okay, so that's called conditional. All right, going to number 8. So when two equally matched teams play a best of 5 series, the odds that one team will win in 3 games is 1-3. So first of all, best of 5 series. You're not necessarily going to play all 5 games. It's best out of 5, so whoever wins 3 games first wins. So when they tell you the odds that one team will win in 3 games, that means they're actually going to win games 1, 2, and 3, and then we're done. We don't need to play the rest, because even if the other team won the last 2 games, they still don't win enough to win it. So they're talking about one team wins the first 3 games and it's over. The odds, now that's different than probability, the odds is 1-3. Okay, so it's not 1 out of 3, it's 1-3. So this is out of 4 possibilities. The total number of possibilities here is 4. 1 in favor of and 3 the opposite. Okay, so 3 ways to not have that happen, 1 way to have that happen. Total of 4 possibilities. So using that information, what's the probability that one team will win in 3 games? Now, it doesn't say the odds. It says the probability. So the odds is 1-3. The probability of that happening is 1 out of 4. So probability is out of the total, and this is 25%. And odds is comparing your favorable outcomes to your non-favorable outcomes. So they're a little bit different. Number 9, probability an event will occur is 5 out of 12. So this is your total possibilities. These are the favorable ones. So what are the odds in favor? Odds now in favor. So it's 5 to, now it's not 5 to 12. It's 5 out of 12. So if 5 are in favor and 12 is the total, that means there are 7 unfavorable outcomes. So if I add 7 and 5, I get my total. And what are the odds against the event occurring? So that's just the opposite of this. There's 7 unfavorable outcomes compared to 5 favorable outcomes. That's letter A and letter B. Okay, number 10, use always, sometimes, but not always or never. If P is the probability of an event and Q is the probability of its complement, then the value of P plus Q blank equals 1. And that's just always. If they're complements, you add their 2 percentages together, you get 100%. You add their probabilities together as fractions, you get 1. 11. So a heart is chosen from a standard deck of playing cards. We need to find the complement of that. And they explain, if you don't really know what a deck of cards looks like, they explain all of it. So a heart is chosen. If we're looking for the complement, we're looking for all the other possibilities that get us to 100%. So you either took a heart or not a heart, which would be your spades, your diamonds, or clubs. And this would be the answer to the question. So if I add these 2 possibilities, so I either took a heart or the complement is I got spades, diamonds, or clubs. If you add them together, you cover all of the possibilities. There's no other possibilities besides these. Now, if you randomly threw in, say, jokers or something like that, now they're not complements. You'd have to include jokers in one of these groups to make sure that you cover all your possibilities if they're complements. Okay, so if I add this and this together, it covers all the possible things I could choose. So number 12, the complement of being born on a weekday, all the other possibilities would be being born on a weekend. If you add the possibilities of weekdays and weekends together, you've covered all your bases. That's what makes them complements. All right, now we're going to deal with probabilities picking from standard deck of playing cards. So number 13, determine the probability of choosing the ace of spades. Okay, so again, every single one of these groups, hearts, spades, diamonds, clubs, those are called suits. Each one of those has an ace through a king. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 different hearts, 13 spades, on and on and on. And if you added 13 and 13 and 13 and 13, you get 52. So total number of cards is 52. So the ace of spades is one specific card. So the probability of getting that is 1 out of 52. So that's letter A. Letter B, what is the probability of getting a 5? So again, this is always going to be out of 52. How many 5s? Well, there's a 5 of hearts, there's a 5 of spades, there's a 5 of diamonds, and a 5 of clubs. So there's 4 out of 52. And you always want to simplify. So I can divide these by 4. And remember, your calculator will make simplifying easy on you if you just bring up the fraction button. Put 4 out of 52. It'll simplify it down for you. That's 1 out of 13. And letter C, a 5 or a 9. So we already did 5. There's 4 5s. That means there's also 4 9s. 1 heart, 1 spade, 1 diamonds, 1 clubs. So we have a total of 8 out of 52. And if we simplify that one, that's 2 out of 13. Okay, 14. Still working with our deck of cards. So determine the probability of selecting each card. So what club? We said there's 13 clubs out of 52. You could also think about it. The deck is split into 4 pieces, and you're picking one of those pieces. 13 over 52, when you simplify it, comes down to 1 out of 4. Part B, a club or a heart. So 13 and 13, 13 hearts, 13 clubs. That is 26 out of 52. And if you're taking 2 out of the 4 spades, you're taking half the deck right there. This simplifies down to 1/2 because 26 is half of 52. And letter C, a club or 5. And it specifically says this is a tricky one because the reason this is tricky is you cannot just add all your clubs, which is 13, and all your 5s, which is 4 5s total, because one of those 5s is included in those clubs. So once you take out your 13 clubs, you've taken out one of your 5s. So there's only 3 5s here. So this is going to be 16 total. So 13 clubs plus the 5 of hearts, the 5 of spades, the 5 of diamonds. We've already counted the 5 of clubs. So 13 total clubs, 3 more 5s, 16 out of 52. And we go ahead and simplify that. So 16 and 52. And we're going to get 4 out of 13. All right, 15. If you know the card you have selected is a face card. So now we're talking about conditional probability. We're not talking about the whole deck. We're talking about a certain condition. So it's a face card. We know it's either a jack, a queen, or a king. So we have those 3 groups. What's the probability that it's a king? There's the same number of jacks as queens as kings. So each group is equal. What's the probability that it's a king? So I already know it's 1 out of 3 because it's either a jack, a queen, or a king. So it's 1 out of 3 that it's a king. But if you wanted to get a little more specific with it in terms of the total number of cards, think about how many cards there are. There's 4 kings. And if you add it up, the total amount of cards we have here that are face cards, 4 and 4 and 4, there's 12 total. 4 jacks, 4 queens, 4 kings. 12 cards total. If we know it's a face card, 4 of those are kings. And so that does simplify down to 1 out of 3. All right, 16. We are looking at this chart. We've got 5 suspects for this crime. Each one has a little bit different demographics here. If chosen at random, what's the probability that suspect 3 is the criminal? So if we know it's one of these 5 people, what's the probability of suspect 3 if just chosen at random? So there's only one suspect 3 out of 5 total. So that's a 1 out of 5 chance. Part B. The detectives get some evidence and they know the criminal is a female. So that eliminates this male and this male. So we only have 3 suspects. What's the probability that suspect 3 is the criminal, which is one of the females? So we've eliminated the males. There's only 3 possibilities. What's the chance it's suspect 3? It's 1 out of the 3 remainers. And letter C. They get evidence that the female criminal is between 5'5" and 5'9". So look at this female. She's between 5'5" and 5'9". This one's between 5'5" and 5'9". This one's not. So she is eliminated along with the males. So there's only two suspects that fit both of those things, that they're between 5'5" and 5'9", and they're female. So there's only two. So what's the probability now that suspect 3 is the criminal? It's a 1 out of 2 probability. Okay, the numbers 1 through 200 are all put in a hat, and something is chosen. Determine the probability that X, the number drawn, is 135, that number. So from 1 to 200, there's only one number that's 135. Total number of possibilities here is 200. And so there's a 1 out of 200 possibility that the number chosen is 135. Part B. What's the probability of getting a number greater than 99? So that's 100 all the way up to 200. So you might just jump on that and say it's 100 numbers. But if it went from 101 to 200, that's actually 100 numbers. And so we got to include 100. If you counted it up, there's 101 different possibilities that are greater than 99. And then letter C, what's the chance that X is less than 1? So 0 was not included. So the smallest number is 1. So the chance that it's actually less than 1 is 0. Cannot be less than 1. Okay, still following along with this same thing. So determine the probability that X is 135 given each circumstance. So now we're going to have some conditional probability. So let's say we know the number chosen is odd. So it's no longer 1 through 200. It's all the odd numbers from 1 to 200. We know it's one of them. What's the chance that it's 135? Okay, so half of these are odd and half of these are even. So that means there's 100 total odd numbers. How many of them are 135? Just one. Part B, the ones digit of X is 5. So we're looking at numbers like 5, 15, 25, 105, all of those, all the way up to the biggest number with a ones digit of 5 would be 195. Okay, so everything in between. If you count all those up, there's 20 of them. If you count them out, 5, 10, 15, 20, 25, all the way up to 200, so you'll get to 195. What's the chance or the probability that if you're just choosing out of those numbers that you get 135? So there's only one of those that's 135 out of the 20, so 1 out of 20. Letter C, the hundreds digit of X is 1. So the hundreds digit. So 5 doesn't even have a hundreds digit. 15 doesn't have a hundreds digit. 105 does. Hundreds digit is 1. Okay, so we're going all the way from 100 to 199. You might think that it's 99, but that would be 1 through 99 counting up. So we have to include the actual number 100 again. So there's 100 different possibilities, and the chance of getting 135 out of those is 1 out of 100. And letter D, the tens digit of X is 8. So tens digit. So we're talking about 80, 81, 82. We're also talking about 180 and 181. So the tens digit is an 8. So just we know that already. A number was picked. We know that the tens digit was an 8. What's the probability that the number is 135? That would be 0, because if we already know the tens digit is an 8, it can't be 135. So 0% chance, probability is 0. 19. Somebody buys a raffle ticket and they say the probability of winning the raffle is 1 out of 2, since I'm either going to win or I won't. Those are the only two chances. So I have a 1 out of 2 chance. What's wrong with this argument? So winning versus not winning are complements, meaning it covers all the different possibilities. If you added all those possibilities together, their percentages of happening, you're going to get 100%. So they are complements, but not always equal. So the chance of winning is much less than the chance of not winning. But if you did add those two probabilities, those two percentages together, you cover all your bases, you get 100%. So complementary events do not necessarily have equal probabilities. Okay, number 20. So we're going to work with some variables here. The television station has scheduled N hours of news, C hours of comedy, D hours of drama, S hours of sports, and X hours of other programs during the week. What is the ratio of hours of news to hours of drama? So you're just comparing the two traditionally as a fraction. So for letter A, you're comparing news to drama. So it's N compared to D. That's a ratio. So letter B, what is the ratio of hours of sports to the total number of hours during the week of all programs? So you're comparing sports to the total. So if I needed the total number of hours, I'd have to add up all the hours of news, comedy, drama, sports. I'm not taking sports out. It's the total. So I need to add up N, C, D, S, and X to get the total. And this is the ratio comparing the two. $21. This family earned $48,735 last year on their 95-acre farm. What is their income per acre? So the dollars they earn per acre. So you're going to set up your ratio in that rate in that order. So dollars on top divided by acres on the bottom will give you dollars per acre when you actually go and divide those. So 48,735 divided by 95. You get exactly 513. So it's $513 per acre. And that's part A. And part B, is there income per acre a ratio or a rate? And those two often get confused. So a ratio is comparing two things that are similar, of the same units, basically. So that's why we're talking about hours of news and hours of comedy, things like that. Comparing two of the same, you're comparing hours to hours. If you're comparing dollars to acres, okay, two different units, that is considered a rate. So just working on our proper vocabulary there. 22. Okay, the list price of a car is C dollars, so an unknown amount. Find the selling price according to the following conditions. So you pay a 7% sales tax. There's no discount. So you're paying for the cost, which is C, and then on top of that, you're paying a 7% sales tax. We consider C to be 100%. So in total, we're going to pay 107% of whatever the price is. So how do we express that? 1.07 C. So if you knew the cost, you multiply it by 107%, 1.07. That's the price with sales tax. Letter B, you get a 20% discount and there's no tax. So C is the original price. You get 20% off of that. So we need to find the selling price. So it's not going to be 20%. You're not paying 20%. 20% came off. You are paying 80%. So if you want to put 0.80, that's fine. You don't need the zero. So it's 0.8 C, 80% of the price. And now letter C, you pay a 7% sales tax and you get a 20% discount. Now, this is a little tricky because that sales tax is not on the original price. You get a discount. Whatever you're about to pay after the discount, whatever it actually costs now, that's what you're going to take 7% of. So 7% of something that's on sale is different than 7% of the original price. So it's a little bit different. So we are going to be taking 80% of something. So the price is 80% C. And then we're adding 7% to that. So we're going to take 80%, so 0.8. We need to find 7% of that. So I multiply it by 7%. And a little hard to see here, but that comes out to 0.056. So 7% of 0.8 is 0.056. So this is the price, just the price with no tax. The tax on that, 7% of 0.8 is 0.056. So that's 0.5, if you move that decimal, 0.56% of the original. So the original would be 7%. It's actually 5.6% because we're paying 7% of a smaller amount. So we're going to go ahead and we're going to put those together. So when you add those together, you get 0.856C, which as a percent is 85.6% of the original price. All right, and last one, just solving this equation. So if I'm solving this, I am going to go ahead and combine like terms on this side. So this is a 1D minus a 0.25. That's 0.75D. I still have minus 8.5. So now I'm going to add 8.5 to both sides, leaving me 0.75D equals 16. And so to get rid of the 0.75 from the D, I'm going to divide. So I'm going to get 16 divided by 0.75. And when I go ahead and do 16 divided by 0.75, I get 21.3 repeated, which is 21 1/3. And that's the final answer. And let's say you got that far and you check the answer key. The answer key says D equals 64/3. And you're like, well, how did they get 64/3? Well, is it the same answer? Are they equivalent? You need to be able to check that and not go back and think you got it wrong. 21 1/3 is 21.3 repeated. So what is 64/3? Do 64 divided by 3. And notice it's the exact same number, 21.3 repeated. So these are equivalent to each other. You know you got the answer right. It does not matter which way you express it. Okay, how would you get this? You'd have to move these decimals here. So let's say you wanted to keep this a fraction and you didn't want to simplify it down to this. You move these decimals 2 spots and you're going to end up with 1600 over 75, and you simplify that and you'll end up at 64/3. But 21 1/3 is a perfectly good answer. Even if you said 21.3 repeated, that's still technically a good answer. So any of those are fine.